Objective 9.5, Adding and Subtracting Rational Expressions. Today we're going to continue with our operations with rational expressions, and we're going to again use the same application that I used on the last video. I know the resolution wasn't great, so hopefully you were able to see it well enough to be able to follow it, and we are going to use the same application again today. So again, hopefully the resolution will be good enough that you can follow what's going on. So let's take a look at our objective. Our two main goals here are to be able to find the LCD of rational expressions, and then to be able to add and subtract rational expressions using that LCD. So again, let's go back to what we already know. We already know how to deal with fractions. And when we are adding fractions, we know that we need to find the LCD. Okay? Now, in a case like you see here, where we just have the 3 and the 7, 3 and 7 have no common factors to them. So when there are no common factors, our LCD is simply going to be the product of those two denominators, which in this case will give us 21. So we can go ahead and rewrite each of our fractions, but now using the denominator of 21. Now when you do this, you have to ask yourself, what do I have to multiply by 3 in order to get 21? Well, the answer in this case would be a 7, and so I want to be able to take the 5 also times the 7, so that this ends up being equivalent to this. So we're changing the form of my fraction, but not what it's equal to. So we want equivalent fractions here to what we started with, but using the 21 as the denominator. So when I take the 5 times the 7, I get a 35 for the numerator. I do the same in my second fraction. What do I have to multiply by 7 in order to get 21? So that's going to be 3. So I need to do the same to 9. I need to take 9 times 3 to get my new numerator. And that's going to be a 27. And so now, since I have my common denominators, I'm ready to add my numerators together. And so when I take 35 plus 27, I get 62, and my denominator of 21 just stays 21. Now since this is an improper fraction here, I could take this one more step and change it into the mixed number, which would be 2 and 20 21sts. 21 goes into 62 twice, which is 42. That leaves 20 left over, so 20 21st would be the fraction. Okay, so in a nutshell, the steps that we want to follow when we are trying to add or subtract fractions is, number one, we need to find the LCD. Okay, then once we find the LCD, we want to rewrite the fractions using that LCD. Then, once we have our equivalent fractions, we can do the actual adding and subtracting by adding or subtracting, whichever the case may be, the numerators, but only the numerators. The denominators are going to stay the same. And then finally, number 4, we need to take a look to see if anything needs to be simplified. Okay, a lot of times it will not need to be simplified, but we do need to take a look to make sure. Okay, now I also spoke here just a minute ago about the fact that if our denominators do not share any common factors, then we can just multiply. That's the shortcut. But what if we have denominators that do share common factors? What if our denominators had been a 6 and an 8. Okay, now we're not going to go through whole problems here, but let's just think about this for a second. If we have a 6 and an 8 for our denominators, then we want to look at what the common factors are so that we can tell how to combine things. Okay, and so you may remember doing things like number trees or inverted division. Looks something like this, where our objective is to be able to get the prime factors that make up the number that we're interested in. So here the prime factors are 2 times 3, and for 8 the prime factors would be 2 times 2 times 2. And so when you go to try to find your LCD, you need to use the factor that shows up the most often. So in other words, each of my denominators has a factor of 2, here and here. Okay, but which one has more of them? Well, 6 only has 1 2, whereas 8 has 3 2s. And so when I am looking for my LCD, I need to use the one with the most, and that's going to be the 3 2s, or I could write that as 2 cubed. Okay, then I do the same thing with the 3s. Well, my 6 has 1 3 as a factor, but my 8 doesn't have any. So when I'm trying to find the LCD, I need to use the 3. And so 2 to the third times 3 gives me an LCD of 24. And that's what I would use for my denominator as I move forward. All right, so let's keep all of this in mind as we move in rational expressions. So just like with multiplying and dividing, the idea behind adding and subtracting rational expressions is the same as what we already know about fractions. So we want to keep that in mind as we work these out. So here's our first problem. We have 2x over x plus 3 plus 4 over x plus 3. Now again, if you go back to our steps, our first step is to find the LCD. Well, in this case, we already have the same denominator. So the LCD already exists, which means we also don't need to do step number 2 because we don't need to rewrite. So we're ready to dive right into step number 3, which is to add or subtract the numerators. Okay, and so when we add the numerators, we're just going to get 2x plus 4, because those are unlike terms, so we can't combine them any more than that. And then we keep our denominator of x plus 3. Now, can we simplify that any more than what we have? Well, I hope that you're getting good at this to say no, because we are not going to be able to cancel any x's here. These are not factors, these are terms. And so 2x plus 4, at best, we could factor it to 2 times x plus 2, but doing that doesn't give me anything in common with x plus 3, and so our answer is final. And we can leave it in this form or this form. Either one is fine. Okay, so that's a pretty easy example because we already had common denominators in our fractions. But how about this one? Now we're looking at a problem where we have 5 over 6x squared plus x over 4x squared minus 12x. Now we have unlike denominators, and so our first step is going to have to be to get an LCD. Okay, now if you think about what we did with our numbers, when we had the 6 and the 8, we had to look for common factors in order to set up what our LCD should be. So we need to do the same with rational expressions, and in order to look at common factors, we need to have factored form. So that's our first step here, is to look at each of our denominators and see if any of them can be factored. Now here, the 6x squared really cannot be factored any more than that. It's just 6 times x squared. It basically already is in factored form. But the 4x squared minus 12x can certainly be factored more. And so we want to do that. Oh, actually, hang on here just a second. Sorry guys, I'm trying to get this to, doesn't want to take that out. All right, okay, we'll just work with it, sorry. So we can take out a 4x from both of those terms, and that's going to leave us with an x minus 3. Okay? And so now, as we compare our factors, we want to be looking for which factors I have the most of. So let's start with the numbers. I have the 6 here, I have the 4 here. What would be the least common denominator of 6 and 4? Now if you need to, you could break this down into 2 times 3 and 2 times 2. But hopefully you just can tell from 6 and 4 that the numerical least common denominator would be 12. Next, we would look at the x's. So I have an x squared here, and I just have one x here. So again, if I'm always looking for the most of each factor, then that means I would want the x squared, because that has 2 x's, and so x squared becomes the next piece of my LCD. And then the other factor that I had was the x minus 3 factor. It exists in the second fraction, but it does not exist in the first fraction, and so that just tells me I need to use that 1 from the second fraction. So I now have an LCD of 12x squared times x minus 3. So now let's use our LCD to rewrite our equations with the LCD. So both of our expressions now need to have 12x squared x minus 3 as the denominator. Okay, and so now I need to look at what do I need to multiply my original denominator by in order to end up with this as my denominator. Okay, and again, you can kind of do this piece by piece. So 6, in order to end up being 12, has to multiply by 2. Now, we already have the 5 here. Okay, so that still has to be part of the numerator. But now if we multiplied the denominator by 2 to get the 12, then that means the 5 will also have to be multiplied by 2. Then we look at the x's. Well, I have an x squared here, and I have an x squared here. So those are already the same, and therefore I didn't need to multiply by any more x's to get those to match. But then I need an x minus 3. And there was no x minus 3 in the original denominator, and so that's another factor that I need to multiply by. And so x minus 3 goes in my numerator. Okay, then I do the same thing with my second fraction. I have a 4 here. I need to end up with a 12. I already started with the x, and so the 4 times what gives me 12, that's going to be a 3. And then I look at my x's. I have an x here in the original, but I have an x squared in the denominator that I want. So I'm going to need to multiply this x by another x to get x squared. Okay, so I'll need to multiply by another x there. And then finally, the x minus 3 factor that I have in my in the denominator that I want, well, that was already part of the denominator I started with, so again, I don't need to multiply by anything more because we already have a match. All right, so now it's time to simplify and combine. And what I would recommend is in the next step, you kind of do two things at once. We're going to simplify each of these numerators that we have and go ahead and combine them all into a single numerator all the way across. But when you do this, I would still recommend that you put each numerator in parentheses. Okay, it's just a good habit to get into, and I'll show you why in just a minute. So here we have the 5 times the 2, which is going to give us a 10. But then that 10 gets multiplied by this factor of x minus 3. So we're going to have to distribute that. So my numerator from the first fraction is going to end up being 10x minus 30. Okay, now I'm going to add, and in my second numerator, right here, if I take x times 3 times x, then I'm going to end up with a 3x squared. And all of that is still over 12x squared times x minus 3. Okay, and so now all we need to do is combine the numerator. And since the parentheses don't actually change the order of operations at all here, I can rewrite this quadratic numerator that I have in standard form, meaning the 3x squared should go first, and then we'll have a plus 10x, and then we'll have minus 30, all over 12x squared times x minus 3. Now remember, our final step is that we need to check to see if this can be simplified. The only way it can be simplified is if we can cancel common factors, which means the only way we can cancel common factors is if this can be factored. So if you take a look at this 3x squared plus 10x minus 30, and you try to take the 3 times the negative 30 using the Xbox method that we've done in the past, you're going to find out that there's nothing that multiplies to a negative 90 and adds to 10. And so because of that, then, there's no way to factor this nice and neatly, and therefore there's nothing that can be canceled between these two. And so, this is it. This is our answer. Okay? Let's try another one. Again, our first step is to figure out the LCD. And to do that, we're going to need factors. So in my first denominator here, x squared plus 4x plus 3, I'm going to factor that into x plus 3 times x plus 1. In my second denominator, x squared minus 9, that's a difference of squares, which can be factored into x plus 3 times x minus 3. So when I look at the factors that I have in the first denominator and the factors that I have in the second denominator, I need to pick out the common factors and take the one that has the most. So I do have a common factor of x plus 3 in both of them, but since they each only have one x plus 3 as a factor, I'm only going to use one x plus 3 for my LCD. I also have a factor of x plus 1. Since it only occurs in the first denominator and not in the second denominator, then I'm just going to use that x plus 1. And I also have this factor of x minus 3, but again, it's only in the second denominator, not the first. And so an x plus 3 will be needed as well. All right, so step 2, the rewrite. So I need x plus 3, x plus 1, x minus 3 as my denominator. And we need that for both. Okay? And so now, if I take and compare the original denominator with what I now need for a denominator, I already have x plus 3 matching. I already have x plus 1 matching. And so I need to take the x minus 1. Okay, so I need to take the x minus 1 that I already had up here, and I'm now going to take that times the missing factor, which is the x minus 3. I'm going to need that multiplied in the top as well. Okay, everybody see that? So x plus 3 already had. X plus 1 already had. But I need the x minus 3, so I would have had to multiply by x minus 3 over x minus 3 to get an equivalent fraction. Okay, same thing with our second fraction. Compare the original denominator with what I need. So I already have an x plus 3 right here, and I already have an x minus 3 right here. The factor that I need is the x plus 1. And so the x that I started with is going to be multiplied by x plus 1, so that I have this overall value of 1 here that I'm multiplying by to get an equivalent fraction. Alright, so now let's do some combining and simplifying. So first I'm going to FOIL this first numerator, and I'm going to put that in parentheses. So this is going to be x squared minus 3x minus 1x will combine to negative 4x, and then plus 3. So that's my FOILed, still over x plus 3, x plus 1, x minus 3. Okay, then I'm going to distribute the x here and also put that in parentheses. So really, I just want this line to continue on, put my plus up here. So this, my second numerator, will be x squared plus x. And all of that is over this denominator. Okay, so now when I combine my numerator, I'm going to get a 2x squared minus 3x plus 3, all over x plus 3, x plus 1, x minus 3. And again, if we try to factor this numerator, we'll find that it does not factor nice and easy. So that means there's no factors to try to cancel with anything down here. So we're done. There's nothing to simplify. Oh, excuse me. All right, up here. Oops, sorry guys. So it's your turn. Take 4 over 3x cubed plus x over 6x cubed plus 3x squared and see if you can come up with the answer to this problem. Go ahead and pause your video for just a moment while you work, and then come back to find out what the answer is. Alright, so for the answer, we're going to start by finding our LCD. The 3x cubed does not need to be factored, but the 6x cubed minus 3x squared can be, which will be 3x squared times 2x plus 1. The 3x cubed and the 3x squared are already pretty similar. The 3 will definitely be part of our LCD. For the x's, I want to pick the one with the most, so that's going to be the x cubed. And then for the 2x plus 1, there's only one of them, and so that also needs to be included as part of my LCD. All right, so the rewrite is going to look like this. 3x cubed times 2x plus 1 plus 3x cubed times 2x plus 1 All right, and so the 3x cubed is already there, so the 4 here is going to be multiplied by 2x plus 1. And here we've got the 3, the x squared, and the 2x plus 1 already in common, so the x I had is just going to get multiplied by another x. So when we combine things, we're going to get an 8x plus 4 plus an x squared all over 3x cubed times 2x plus 1. And in our final step, we end up with x squared plus 8x plus 4 all over 3x cubed times 2x plus 1. All right, so let's subtract rational expressions now. Basically, the format is the same. The steps are the same. We just have to be a little bit careful because the subtraction can trip us up sometimes if we're not paying attention. So again, we're going to start by figuring out our LCD. And to do that, we need to factor. And so x squared plus 4x plus 4 is going to factor into x plus 2 times x plus 2. And our x squared minus 4, that's a difference of squares, so that'll be x plus 2 times x minus 2. So when we look at our factors, the x plus 2 factor, we have 2 of them here, but only 1 here. So that means in our LCD we want 2 of them, and we can write that as x plus 2 squared. Excuse me. And then for our x minus 1 factor, we just have the 1, and so we'll need that as part of our LCD as well, x minus 2. All right, so now we go to the rewrite stage. So x plus 2 squared times x minus 2 minus x plus 2 squared times x minus 2. All right, so here we have 2 x plus 2's. To start, we have 2 x plus 2's right here. The factor we're missing is the x minus 2, and so that's what we're going to have to multiply by. So the x plus 1 that we started with will be multiplied by the x minus 2 that we had to add, or I should say multiply by, in order to get it into our new denominator. In the second expression, we have the x minus 2 this time, but we only have 1 of the x plus 2's, and so we need another one, which means the 2 that was there is going to get multiplied by an x minus 2 as well. All right, so my first numerator, when I FOIL this, is going to become x squared negative 2x plus 1x is going to give me negative x, and positive 1 times negative 2 will be negative 2. Subtract the second numerator, which is going to be 2x minus 4 when we distribute the 2. And again, all of that is over x plus 2 squared times x minus 2. Now here's where we can run into trouble if we're not careful. This subtraction applies to everything in the second numerator. And so this is why I'm saying it's a good habit to write the first numerator in parentheses and then the second numerator in parentheses, so it's more obvious that we need to distribute this negative to both of our terms. Okay, so I'm going to have the x squared And then I'll have a negative x minus 2x, which will give me negative 3x. And then I have a negative 2 minus negative 4, which is going to end up being plus 2. All of that still over x plus 2 squared times x minus 2. Okay? All right, so on with subtraction, just to see if you get the hang of it. Pause the video for a moment if you need to. Come back when you're ready to check. All right, so for our last problem here, our LCD is going to depend on the factors. Here, our factors are x plus 3 times x plus 3. And here, the difference of squares will give us x plus 3 times x minus 3. So very similar to the last problem we just did. So for the LCD, I have 2 x plus 3's here compared to just 1 over here. So I'm going to need 2 of them in my LCD. And we'll say that by squaring it. And then for the x minus 3, we just have the 1 that's here, nothing over here. So I just need the 1 x minus 3 to complete my LCD. When we rewrite, we're going to have x plus 3 squared times x minus 3 for denominators. Okay, and so here, 2x plus 3's, that's what I've got here. What I'm missing is the x minus 3, and so that's what I'm going to multiply by. The x plus 1 I started with times the x minus 3 that I need. Here I've got a 1x plus 3 and 1x minus 3, so the x minus 3's are already matched. I have one of the x plus 3's, I need a second one, and so the one that was there gets multiplied by the second x plus 3. And so now when I FOIL the first numerator, I'll get x squared minus 2x minus 3. And in the second numerator, I'll just have x plus 3, because we're just multiplying by the 1. All that is still over x plus 3 squared times x minus 3. And so now when I distribute my negative sign here, I'm going to end up with an x squared minus 3x minus 6 all over x plus 3 squared times x minus 3. All right, so hopefully that's the answer you got. And now you're ready to move on to your practice. So if you have any questions over any of these concepts, please make sure you ask in class. Otherwise, you can be working on the 9.5 practice during class. And when you finish with that objective, make sure that you show me your booklet so you can get the objective checked off of your list. And that should do it for today. We'll see you next class.